All right, let's just jump right in. For decades, right, we've been told that most of our universe is this huge, complete mystery. But what if the biggest puzzles in all of cosmology, I'm talking dark matter and dark energy, what if they aren't actually mysteries we need to solve? What if they're just mistakes we need to fix? What if they don't even exist?
So just look at this. This is the picture of the universe you see in every textbook. And it's kind of mind-blowing, right? A whopping 95% of everything is made of this dark stuff that, honestly, we just can't see or explain. But here's the big question. What if this entire picture, the very foundation of modern cosmology, is just wrong? That's the super provocative idea we're going to dig into today.
So here's how we're going to break it down. First, we'll cover the standard story. The usual explanation for these big cosmic mysteries. Then, we're going to introduce a pretty radical new theory about the very fabric of reality itself. We'll see how it totally rethinks dark matter, calls dark energy into question, and, well, gives us a completely new way to look at the cosmos.
Okay, so let's really get a handle on just how big this problem is. When we say the universe has a dark secret, we're not kidding. We're talking about a 95% problem. Just let that sink in for a second. Everything we know, everything we can see and touch and measure, all the stars, galaxies, you, me, all of that is just 5% of the universe. The rest? It's a massive question mark. And honestly, it's led to what a lot of people are calling one of the biggest crises in the entire history of physics.
All right, so before we get to the radical new idea, we've got to understand the standard story, right? The explanation you'll find in pretty much any textbook. So let's meet the two usual suspects that physicists have come up with to explain that missing 95%.
First up, we've got dark matter. You can think of it as the universe's invisible glue. The whole idea is that galaxies are spinning so fast they should just fly apart, right? So the theory goes there must be some kind of undiscovered particle out there adding extra gravity to hold everything together. We can't see it, we can't touch it, but we assume its gravity must be there.
And then you have dark energy. This is the flip side, the mysterious force that's apparently pushing everything apart, faster and faster. The main piece of evidence for this comes from looking at light from really distant galaxies. We see that this light has been stretched out, which makes it look redder than it should. You've probably heard of it. It's called redshift. And the standard way to interpret this is that space itself is expanding, and it's actually accelerating. It's speeding up.
But what if we don't need either of these mysterious, invisible things? A really fascinating new perspective argues that the problem isn't out there in the universe, but right here, in our understanding of it. It suggests we need a totally fundamental shift in how we even picture the fabric of reality.
And this slide, wow, it just nails the core idea. See, standard physics, which is all based on Einstein's general relativity, it kind of treats reality as two separate things. You've got space-time over here and energy over there. And yeah, they influence each other. But this new theory, it proposes something much simpler, more unified. What if reality is just one dynamic thing? A single elastic fabric?
So the key difference, the real game changer here, is this idea of elasticity. Think about it. In the standard model, space-time is kind of passive. It's like a stage that gets shaped by the actors, the energy. But in this new model, the fabric of reality isn't just a stage. It's an active participant. It can stretch, it can ripple, it can change all on its own, without needing something else to push it around. Okay, so with that in mind, let's see how this whole elastic fabric idea gets rid of the need for dark matter. And the answer is, well, it's surprisingly elegant. It's not a particle, it's a wave.
So, according to this new theory, what we've been calling dark matter isn't matter at all. The extra gravity we see, it's just the shape of the fabric of reality itself, a really big, slow-moving wave or ripple. The technical term is a non-fermionic shape, which, yeah, that sounds complicated, but it's just a fancy way of saying it's pure geometry. It's not a particle like an electron. It's a wave in space-time, not a separate thing moving through it. See the difference?
Now, here's what's really wild about this. The source argues this isn't some brand new math they just invented. Nope. The potential for these shapes, these waves, was apparently hidden in Einstein's original equations the whole time. It's like physicists were looking on one side of the equal sign, searching for a source of energy to explain the universe's shape, when they should have been looking at the other side, realizing the shape could have a life of its own.
All right, so that's dark matter taken care of, maybe. But what about the bigger piece of the pie? Dark energy. Well, this new theory suggests it might not be real at all.
It could just be an illusion, something born from us misinterpreting the data.
So if you're going to question dark energy, you have to go back to the source. You have to question the evidence it's built on. And it turns out the entire idea of an accelerating universe really hinges on one specific type of measurement.
And that measurement is redshift. We talked about it a bit already. In standard physics, it's pretty simple. When we see light from a distant galaxy that's been stretched out towards the red end of the spectrum, there's really only one main explanation. That galaxy is flying away from us. And the more stretched the light, the faster it's going. That line of reasoning leads you straight to the conclusion of an accelerating universe.
But if reality is this elastic fabric, things suddenly get a whole lot more complicated. This new theory says, hold on a second. It proposes there could be at least 4 different factors that cause redshift. On top of the simple movement of galaxies, you could have things like the fundamental particles changing size, or maybe even the speed of light isn't as constant as we thought. The fabric itself could be stretching light waves.
So, you see the problem, right? If any of these other factors are even partially responsible, then our one simple interpretation just falls apart. It's not so certain anymore. And as the source material puts it, concluding that dark energy must exist might just be jumping the gun. It's like we're speculating on a solution before we've even fully understood the problem.
So where does this leave us? What's the big takeaway here? Look, whether this specific theory turns out to be right or wrong, it forces us to ask some really important, fundamental questions.
The main point isn't just about dark matter or dark energy. It's about how science works. Maybe, just maybe, the answer to the universe's biggest secrets isn't about finding some new, exotic thing. Maybe it's about taking a huge step back and questioning the very assumptions, the very framework we're using to look at the universe in the first place.
And that brings us to the ultimate test, right? Because a good scientific theory has to make a bold prediction, something you can actually go out and prove wrong. And this theory does exactly that. It makes a super clear prediction. The decades-long, multi-billion-dollar hunt for dark matter particles, it's going to fail. Why? Because there's simply nothing there to find.
So I'll leave you with this final thought. We have spent billions of dollars and just countless hours searching for new particles, for new energies. But what if, this entire time, the answer wasn't about adding more complexity to our models? What if it was about seeing the universe from a completely different, maybe even simpler perspective? What if the problem isn't what we're looking for, but how we're looking?